Okay, this video is covering permutations and combinations. So it's talking about the similarities between them and how they differ. So I'm going to start actually on a nice little Excel spreadsheet here. And what we have in the upper left is going to be a table on permutations. Basically what I'm asking is, I have the numbers 1 through 5, 1, 2, 3, 4, and 5, and I want to fill 3 different spots. How many different ways can I fill those 3 different spots? You'll see you have obviously 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 2, and you can go through all these. In total, we have about 60 different permutations that we can find. Permutations care about order. And when I say they care about order, what it's saying is numbers 1, 2, 3 and 2, 1, 3, even though they have the same numbers, they're different. Combinations is asking the same question, but any redundancy is kind of taken out. So 1, 2, 3, 2, 1, 3, and 3, 1, 2 are considered all the same. And we're going to delete those. You'll notice that even though we have the same numbers and the same 3 spots to fill, we only have 10 total combinations in this sense. So I'm going to kind of walk you through a few things, but I'm going to go back to this page. This is where we actually have formulas set up. This is kind of the reason for the videos. These formulas I don't think are very well explained. So what we have is, again, we had 1 through 5. So n is going to be 5. So we basically have 5 different numbers to choose from. K in this formula is going to be how many slots. So we have 3 slots. You can think of 1, 2, and 3 that we're filling. And so that's what's going to be filled into these formulas here. At the top, you have n factorial. What that means is you have 5 times 4 times 3 times 2 times 1. On the bottom, you're going to have the difference between n and k. So 5 minus 3 is going to be 2, and that's going to be factorial, so 2 times 1. What's really nice about this is you can actually just cancel out top and bottom, the 2 and 1, and it becomes 5 times 4 times 3. If you do the math, that's 60. Going back to our spreadsheet, that's the number we got here. So everything's looking good. If we come back here, though, combinations, I didn't fill out the formula quite well enough. So what we're missing is actually going to be k factorial, which is going to be, in this case, 3 times 2 times 1. K is 3. And what I want to point out is what these 2 bottom numbers are representing. So if you think about this, n factorial is really simple. If you had 5 spots to choose, in the first spot, you could have a choice of 5 different individuals. In the second spot, you could have a total of 4 different individuals. In the third spot, you could have 3. In the second spot, you could have 2. In the final spot, you only have 1 left over, right? So it'd be 5 spots times 4 times 3 times 2 times 1. That's actually how you're going to have that no matter what. But in our case, we don't have 5 spots to fill. We only have 3. So we're going to cross that out, and we have our first 3 spots. So that's 5 potential individuals in the first spot, 4 in the second spot, 3 in the third spot, and then technically you still have that 2 and that 1 left over. That 1 left over, but we don't have any spots for them. So if you look over here, where did that come from? Well, that's actually what we're doing with this denominator. We're removing those extra spots. And no matter how you kind of denote this, you know, however many spots you're filling, whether it's, in our case, anything up to 5, that denominator is going to account for that, and that's going to remove that. So it's really kind of, in my opinion, fairly obvious what you're doing with permutations with that denominator. Even though it looks a little strange, that's what you're doing. It just so happens that that's a clean way to do it, regardless of how n or k change. You can fill that into the formula. But that's what you're doing. You're just removing those extra spots. With combinations, you have this strange additive of k factorial. And the question is why? And if you come back over here, we're going to look over here on the combination side. So I had mentioned that combinations, let's say they don't care about order, right? So regardless of whether it's 1, 2, 3, 2, 1, 3, or 3, 1, 2, it's considered all the same. It just means you have those 3 numbers that are being used. So down here, we have our original 1, 2, and 3. These are all the copies of that same same number, right? Or that same combination. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. If you count them, it's 6 total. So what we're taking is 1 out of the 6. So let's come back here. If I fill out my formula here, right, I have for combinations, I'm going to write that down. So for combinations, I have n factorial over k factorial times n minus k factorial. So if we were to write this out, we have 5 times 4 times 3 times 2 times 1. And then we have our n minus k factorial, which is going to be 2 times 1. And over here, it is 3 times 2 times 1, right? K factorial, k was equal to 3, so we do 3 times 2 times 1. So what we're left with is we essentially can cancel these out, right? And we have 60 on top, and we have 6 on the bottom. So it gives us a total of 10 different combinations. But let's see what we're actually doing here. Why do we need to add this in? Why does it kind of work that way? Well, in this case, we're taking 1 out of 6. So if we back up on this formula here, let's take k out. And let's just worry about the permutation side of things. So if we move over, we can do 5 times 4 times 3 times 2 times 1. And we have that permutation side is going to get rid of that 2 times 1. And I can go ahead and cancel that out. But then what I'm going to do is say, okay, here's our number, but let's just take 1/6 of that. Because I know that for every combination of 3 numbers, I only want 1 out of every 6. Because all of these have patterns as far as how they're combined. You have the same number kind of as you go through. If you notice, we have 1, 2, and if 1 and 2 follow each other, right? 1, 2, 1, 2, 1, 2. Here's 2, 1, 2, 1, 2, 1. Here's 3, 1, 3, 1, 3, 1. And then it transitions through those numbers. There's a pattern as you go through that. So what this k factorial is doing is just ratioing out the original permutation. For a better example, we can actually get larger numbers. So with the same 1 through 5, I'm going to add it to 4 spots, and all of a sudden you're going to notice it gets a bit bigger. So in our case here, we have all of the possible permutations that you can put in here for 1 through 5 in 4 spots, and then here's all the combinations. So coming back here, let's do the math on that. So let's make a clear screen here. So for the permutations, it's going to be n factorial over n minus k factorial. N is equal to 5, k is equal to 4. So we have 5 times 4 times 3 times 2 times 1. And in this case, n minus k is just 1. 1 factorial is 1. So I can cancel that out. 5 times 4 is 20, times 3 is 60, times 2 is 120. So for the permutations, I should have a total of 120 different permutations. If I count them, I actually just did a little Excel count option here, and you have 120 total. So we're good. And I color-coded them just to show you that this is all the 1 and then followed by the 2s right here. And then it moves into 1 followed by 3s, and then 1 followed by 4s, and 1 followed by 5. So it gives you a better idea of what's going on. Here, this is the copy of all that, but I've deleted all of the copies. Okay, I've deleted every number that doesn't that isn't a replica, or that, excuse me, every number that is a replica of one of the originals. So in this case, we only have 5. And let's actually do the math on that. So here, if we have n equals 5 and k equals 4, we're going to do a combination. So the combination formula is n factorial over k factorial times n minus k factorial. Filling it in, you get 5 times 4 times 3 times 2 times 1. N minus k factorial is just going to be 1 again. And then k factorial is going to be 4 times 3 times 2 times 1. And look at that. We can cancel that out and cancel that out. And cancel that out. So we're left with 5. Okay, so much smaller number. Why is this? So why did it get so much smaller? Well, here is a list of all of the copies of 1, 2, 3, 4. So you have 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3. You can go through all of them. A total of 24. So what we're keeping is 1 out of every 24. And if we look at the permutations, we have 120 total permutations. If I divide that total by the total of combinations, we're left with 24. So that gives us that same number of basically that same ratio that we've ratioed it out on. So I hope this gives you a better understanding of what a permutation and what a combination is in these senses. I always found that the formulas that they offered was kind of offered at a more of a memorization rather than an understanding level. So I hope this helps you understand it.